Assalamualaikum. My name is Hafizul Azmi, metric number 198610. So today I will explain how to answer the question number 9, which are the secant xn equal to an un is applied to a first differential. Find the response yn which are equal to difference xn. So first of all, the information we get here is first yn equal to different xn, which the different xn we can get it from the previous question. It is question number 8. So different xn is actually equal to xn minus xn minus 1. So we can write here yn is equal to xn minus xn minus 1. From here we can make it as a impulse response, which are hn equal to delta n minus delta n minus 1. So how to get the response? We need to use convolution. So to use convolution, we will need this impulse response here, which are the hn. So I will use the graphical method because I understand it more. So first of all, we need to get the graph for hn, which are the delta k minus the delta k minus 1. So k actually here, k is our unknown. Any words, any alphabet can be used for the unknown, because yn is actually equal to xn times which hn, which equal to summation of x, k, any variable here, times with h n minus k. So my variable here will be the k. So first we need to obtain the hn first. So hn is, like I said before, delta k minus delta k minus 1. So first of all, we need to sketch the delta k, which it will be like this, impulse response, and delta k minus 1, which will delay by 1. So the impulse will be at 1. Here will be 1. So when we minus both these two, we will get this graph, which first of all 1 minus 0 equal to 1, and then 0 minus with 1, which equal to negative 1. So now we have the hn graph. Next we will need the xk graph, which are an n. So an n, we know here that an is a exponential. So exponential will slowly go up into limit. So we can do a graph sketch like this for xk. So what next we need to do is times the xk with the hn, but the n we will change it from 0, from less than 0, which I use negative 1 here, n equal to 0, and then lastly use the n more than 0, which I use 1 here. Okay, so first of all, n less than 0, which is negative 1. So when n is less than 0, we will get h minus n, which is negative 1, h n minus k. So our n is negative 1. So h negative 1 minus k, we will get this graph. So when we times both of these, we will get 0, because the xk will only have value on the positive starting from 0 to the positive value. So when we get a negative value or less than 0, we will get 0. So here we will get 0 for n less than 0. And when n is equal to 0, we will get a 0, which here we can equal it as 1, because any number to the power of 0 will equal to 1. So when n is equal to 0, our yn is equal to 1. This part is not really important, so the most important one is when n is more than 0, because from here it will continue to grow. So when n is more than 0, here I will only use 1. So when n is equal to 1, the h n minus k will equal to h1 minus k. So the graph for h1 minus k will be this, and when we times these two graph, I will get a negative a naught and a 1. So y1 will be equal to negative a naught plus a 1, which when we revise it, it will become yn equal to negative a n minus 1 plus a n. So for response, we need to times it with unit step, so that we will not get any negative value here, any less than 0 value. So yn will become an un minus an minus 1 un. So this will be our response for yn, which we already get from the start, where we only understand the first answer, which it means that an will minus by 1 on the next value. So thank you.